SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we will continue with the standards for surgical face masks or medical mask. So, the performance standards for US and European Union standards. So, US standards actually ASTM standard they follow. So, here we will see the different types of tests. One is BEF test, that is bacterial filtration efficiency. So, BFE not BEF, BFE. So, BFE test bacterial filtration efficiency, and PFE is the particle filtration efficiency. So, bacteria is actually categorized in different way as a separately, and particles are there. So, particles typically of 0.1 micron is used, and bacteria we know the size of the bacteria, and then for penetration synthetic blood penetration is there. So, that test was carried out. So, as per ASTM 1862, and for physical testing the differential pressure is measured, that is pressure drop, and safety the microbial cleanliness, which for ASTM does not recommend such standard, but European Union they have certain standard, and biocompatibility is there. So, there are different types of parameters we used to test, and you can see the bacterial filtration efficiency. In level 1 it should be more than equal to 95%, and level 2 and 3 it should be more than equal to 99%. And similarly for European Union, that is EN 14683, which is developed in 2019, the it is barrier levels. So, type 1 and type 2 it says the more than equal 95%, and type 3 and type 2 and 2 are, sorry, 1 and 1 are, 2 are, it is a 98%. And particle filtration efficiency they do not recommend any such test, where only bacterial filtration efficiency is enough for that. And synthetic blood penetration for type 1 there is no test required, and type 2 it should be more than 120 millimeter Hg pressure, that is mercury pressure, and type 2 are also required more than 120 mm Hg pressure. So, normal type 1 and type 2 they do not require this penetration test, then type 1R and 2R that is meant for the synthetic blood penetration test. So, that is actually graded in such a way. So, let us try to see what is bacterial filtration efficiency testing, BFE. BFE is a measure of how well a face mask can filter out the bacteria when exposed to bacteria contamination aerosol. So, aerosol is actually contaminated with bacteria, and how the filter mask can filter out the bacteria, that is tested. So, it recommends that a droplet containing the bacteria, basically certain bacteria, the average size of 0.6 to 0.8 microns, that is tested. It is to be called a medical and surgical mask. So, if you want to grade it as a medical or surgical mask, so more than equal to 95% filtration efficiency should be there. It should stop that much bacteria. So, high protection if it is needed, then at least 98% efficiency should be there. So, that is graded. If you try to call it as it is a medical or surgical mask, then we should pass this BFE test. To determine the BFE rating, some manufacturer use the modified Green or Vasily method, okay. Greeny and Vasily method. Another part is that particle filtration efficiency test. So, it is a measure of how well a hospital mask filtered the submicron particles. It is used to predict the that virus will also be filtered in the same way. So, if it is actually assumed that if the fine particles are submicron particles are filtered out. So, that is with that assumption that it should protect us from the virus also. High percentage indicate better filtration. So, in ASTM 2100 recommends that testing to be done with a particle size of 0.1 to 5 micron size. Within that size we should try to filter, and next is the fluid resistance. So, where the synthetic blood is injected, splashed on the filter media. So, this is the filter media and synthetic blood is splashed on that, and measure how much penetration is there, and that is in case of hospital and surgical cases. In those cases the blood splash may take place. So, people should get actually protected from this type of splashes. The fluid resistant is the ability of a surgical mask to reduce the fluid transfer from outside layer to the inner layer as a result of splash or spray. The fluid resistant it should be, and ASTM recommends that the fluid should be synthetic blood which is injected at different pressure 80, 120, 160 millimeter Hg the mercury pressure. The pressures correspond to blood pressure. So, this 80, 120 and 160 are they are corresponding to 80 and 120 corresponds to normal blood pressure, and 120 is for during surgery. So, 80 it denotes the vein pressure, that is level 1, the lower blood pressure. 120 is the artery pressure, and 160 represent the it correlates with the high pressure that could occur during trauma or surgery that includes high pressure irrigation. So, that is like in orthopedics during trauma, during something. So, high pressure liquid can come from the infected person, like blood can be can come at that speed. So, these three pressures are as per the corresponding blood pressure at different levels. So, as per the EN 14683, the performance requirement of face masks are, this is the performance requirement. So, BFE, bacterial filtration efficiency, type 1, type 2 and type 3 are. So, type 1 is more than 95%, type 2 98%, and again it is 98%. Differential pressure is less than 40 Pascal per square meter, less than 40 and less than 60, and splash resistance are not required, as we have mentioned type 1 and type 2, because they are not meant for that type of situation, but in type 2R it is a 16, and microbial cleanliness is required, which is not required in case of ASTM. Here it is less than 30. BF test apparatus, you can see this is the test apparatus of bacterial filtration efficiency. Here is the specimen kept, face mask, the specimen which is kept here. Now, the one is that the drive mechanism, here it is a drive mechanism, and 2 is the bacteria suspension. Here bacteria suspension is there, and through this 3 is the nebulizer, which creates the aerosol from the bacterial suspension. Nebulizer is there, and 4 is a HEPA filter. Okay. An aerosol chamber, this is the aerosol chamber 5, the bacteria along with the air it is coming here at this point. High pressure air source is there, this is the high pressure air source is placed, so that this suspension the air mixed with the bacteria can come at high pressure. So, test material is there, this is a test material, in our present case it is a mask. Cascade impactor is here, outlet to sink hose, that is 9 is outlet, here from this there is a outlet. Condenser is there, here it is a condenser which condenses the and cold water is flowing through. Then flow meter is there, this is a flow meter which measures the air flow rate. Compressor for vacuum pump. So, from here we can calculate the how much bacteria is being restricted by the filter medium. Now, let us try to understand the constructional characteristics of the N95 mask. This is a highly efficient respirator mask designed to protect the wearer from airborne particles and aerosols. So, the N95 means N means the it is not resistant to oil particle, that we have already mentioned, and 95 means it can filter out 95% of particle which is more than equal to 0.3 micron. So, that is the definition and under standard testing conditions. So, that is certified by NIOSH, National Institute of Occupational Safety and Health. It is used in widely in the hospital during the COVID-19 or any other pandemic. We can use this. Now, if we see the structure of N95, we can have 5 layer structure. Now, try to see there, this is the N95 mask, 5 layer protections. First layer is the non-woven fabric with a large pores. So, layer 1 outer spun bonded layer which provides the strength and protection of the inner layers, and at the same time it repels the droplet and dust particles. So, this is the outer layer, and large particles it stops. Then the pre-filter layer. So, after that there will be pre-filter layer which actually captures the large particles. Third layer is a fine melt blown layer which arrests the fine particle. So, third layer is the melt blown. This is a melt blown, first melt blown layer, and then second melt blown layer with high efficiency. This is the second fourth layer, second melt blown layer which is main barrier, high efficiency filtration, and then the inner layer, it is a spun bond layer which absorbs moisture and improve comfort. This is the spun bond. So, spun bonded and then melt blown, but here there are 5 different layers to have very high level of protection. This type of graduated structure is important for to get the high filtration efficiency. So, layer 1, this is the layer 1, you can see the spun bonded open structure. So, made from a spun bonded polypropylene nonwoven fabric with lightweight open structure 20 to 30 GSM, which is hydrophobic in nature, hydrophobic finishes are there. It actually repels the water droplet or splashes or even external moisture to keep the inner layer protected or dry, acts as a first barrier against the dust, pollutants and large particles. So, large particles get deposited on that, it is not penetrating through that, and it protects the inner filtration layer from contamination and wetting. So, we see that these are the this is the layer which is very important to protect, to give the support to the inner layers, and it provides the mechanical strength, durability of the mask, because outer melt blown are weak. So, that has to be protected and protected by the spun bonded layer on both the sides. So, it helps maintaining shape and structure. So, it is actually this structure, other structure will be very limpy. So, it gives the stiffness to the structure, so that it maintains its structure. And layer 2, it is a pre-filter layer, this is a pre-filter layer. Again it has got higher pore size, but lower than the outer layer, layer 1, usually made of fine spun bonded fabric or coarse melt blown. So, coarse melt blown or fine spun bonded polypropylene we use, that is finer than the outer layer, that is layer 1, with a GSM of 250. It acts as pre-filter, capturing relatively large particles, dust, and reduce the particle load on the main filter. So, it prevents the large particles. So, larger particles it prevents from going and loading the main filter layer. It helps distribute airflow evenly through the mask, provides structural support to the inner layer, that is melt blown layers. So, due to its open structure, it continues maintaining the breathability. Okay. Layer 3 and 4 basically melt blown layers, the main filtration layer. So, these are the melt blown layers. So, layer 3 are little bit coarser than layer 4. So, they are made of ultra fine melt blown non-woven fabrics, serve as primary filtration barrier, or here if we want very high filtration rate, in that case we can charge this melt blown with the electrostatic charging, and then it is covered by the other layers. Fibers have very small diameter and high surface area. So, enabling high filtration efficiency. So, smaller particles are captured, filter particles through impaction, interception, diffusion, electrostatic attraction. So, this is the main filtration layer responsible for achieving more than 95% particle filtration efficiency. Then inner layer, which is again spun bonded layer. So, if you see, this is the inner layer spun bonded, here it is a melt blown and outside spun bonded. It is usually made of soft spun bonded, outer is a hard spun bonded. So, to give the structural stability, here we have soft spun bonded layer, because we need the comfort. 30 GSM combined with soft non-woven. So, either polypropylene or combined with non-woven we can use this. So, designed to be skin friendly, comfortable, and it should be water absorbent. So, airborne moisture excel, it should be breathable and it should absorb the sweat and moisture, and it helps the filtration layer dry, maintaining the performance. That it provides additional structural support and improves the overall comfort. So, the spun bonded being the larger size of the fiber, that is a higher diameter, they provide the structural support. Now, the filtration may occur through 5 mechanisms, as we have already discussed in general filtration, but in case of face mask also this all 5 mechanisms are used, particularly in the filtration layer. So, air stream is moving with the different types of airborne particles, like droplets are there, small particles, virus, bacteria are there, it is there. So, inertial impaction is there. You can see this is the inertial impaction, where the large particle coming with higher inertia, it will get impacted on the fiber cross section, and it will get settled within the structure. So, large particle cannot follow the air flow around the fiber due to the inertia. So, that will get captured, they collide with the fibers and get trapped inside, there is a collision. Next is the interception. Interception, you can see here, the particles follow the air flow, come close to touch the fiber. So, air flow is there and it is close to that, and it will get stick to the surface, where there is a narrow path. So, narrow path will be there, where there will get entrapped at that on the surface of the fiber. Then diffusion. So, very small particles less than 0.1 micron, typically the bacteria, virus in the air, they move randomly, okay, random motion, Brownian motion, and then random motion increases the probability to get the fiber in contact with the fiber surface, get the particle will in contact with the fiber surface and get settled there. And last one is electrostatic attraction. If we charge the fiber with some electrostatic charge like positive charge, and the particles with negative charge will get attracted on the surface. So, that will enhance the filtration efficiency without increasing the pressure drop. So, it will keep the air flow rate intact. Now, what are the pros and cons? So, of the N95 mask? So, high filtration efficiency of particle more than equal to 0.3 micron, provide a tight facial seal including reducing the air leakage, effective against airborne particle, aerosol and pathogens, widely used in healthcare industry and industrial environments. So, multiple filtration layer provides reliable and it is a high protection against the different diseases such as COVID, and the drawbacks are basically due to the multiple layer. So, breathing resistance is higher than the cloth and surgical mask. So, the breathing problem will be there with this type of mask, requires proper fit and seal to work effectively, can cause discomfort during long use, usually single use is there or limited reuse which enhance the ecological impact, it higher cost compared to the basic mask. So, these are the different problems of the drawbacks of the N95 mask, and there are other variants of N95 mask is there is a cup type model which is molded N95. You can see this is the N95 which is molded outer layer, cup type, rigid and preformed cup to maintain the shape. So, in place of spun bonded, here we use the porous, the rigid cup is used, provide stable seal and consistent fit. So, commonly used for healthcare and industrial environment. Next is the foldable or flat fold N95. So, this is the foldable which is very commonly used, flexible design that can be folded easily, expands to fit the face, convenient to transport and individual packing. So, that can be folded and packed if we want. So, with exhalation valve. So, this is there is a exhalation valve is there that we have discussed. It includes a one way valve to release the exhalation of air, it reduce heat and moisture built up, making breathing easily. So, during exhalation it will open, it will actually allow the exhaled air to pass, so that the inner breathing will be easier and the temperature, moisture built up and heat built up is reduced. So, industrial setting we use are not preferred for infection control, because for infection control if there is a opening, if there is any gap, then the performance will be deteriorated, that is why it is not recommended. Surgical N95, you can see this is the surgical N95 which is lighter in weight. So, special N95 designed for medical and surgical environment, provide both particle filtration and fluid filtration. This is basically the protected from the splash or blood splash, used in hospital during the high risk area exposure to the infectious agents. Now, the surgical mask is also one variant of mask. So, apart from N95, this is surgical mask, it is not that type of stringent requirement is there like N95. It is a disposable face mask designed to reduce the spread of the respiratory droplets. That is here the filtration efficiency is not that stringent, but here only the droplets, respiratory droplets, it should not be spreaded. Primary use to source control, like when a person is actually is wearing that from his nose or mouth, it should not, the respiratory droplets should not come out. Okay. And for infected person, they wear these things, that with a cough they should wear this type of surgical mask, typically consists of 3 layer non-woven. So, 3 layer basically, again here it is a spun bonded, melt blown spun bonded structure. So, outer layer is protective layer, middle layer is mainly filtration layer and inner layer is comfort layer, made mainly from nonwoven polypropylene nonwoven and spun bond melt blown process, provide barrier protection against the droplets, splash and large particles, commonly used in hospital clinics. So, it helps in reducing the respiratory disease, transmission of respiratory disease like influenza, COVID. But due to this structure, that is it lose its fitting structure design, therefore, does not provide tight facial seal like N95. So, because of this structure, the not that rigid flexible structure, it gets the fitting gets disturbed. So, if you see the layers here, so we have the outer layer which is blue in color, that is the fluid resistant layer. Outermost layer is made of the spun bond fabric, blocks large droplet saliva, and then middle layer which is high efficiency filter layer, typically it is melt blown. So, it provides fine dust, pollen, aerosol, bacteria, it gets filtered out, and also the inner layer is hygroscopic, innermost layer, which is basically which provides the comfort to the human skin, and the outer layer is basically made of spun bond nonwoven fabric with random orientation. Usually polypropylene is used, and it is hydrophobic, water repellent. So, sometimes water repellent finishes are applied to give the fluid resistant and resistant to droplets. Primary function, it acts as the first protective barrier against external contaminants such as dust, droplet, splashes, and the filtration role is it captures the large particles through the mechanical filtration like impaction and interception, and its protective role is it prevents the liquid from penetration and it repels the liquid, and it helps the main filtration medium, the second layer, to maintain its filtration efficiency. So, it does not, so that the main filter does not get disturbed. It provides a structural strength to the mask, and next is the middle layer which is made of fine melt blown fabric nonwoven with a very fine fiber densely packed, and which provides the mainly filtration. So, surface property is often it is electrostatically charged if we need to enhance the filtration efficiency, otherwise mechanical filtration is done, and primary function is to maintain the as a filtration barrier, remove fine particles and microorganisms, captures particles through mechanisms such as diffusion, interception, electrostatic attraction. So, main filtration roles are there, and it provides high filtration efficiency and improves the mask performance. And most critical layer in determining the filtration efficiency, and inner layer is a soft spun bond nonwoven, relatively large fiber, and which gives typically like N95, it gives the soft touch comfort, typically non-woven, hydrophilic or moisture absorbent. It should soft in handle, and it absorbs moisture from breathing and sweat because of its high wicking characteristics, which improves the comfort, and protection role, it keeps the middle filtration layer maintained. So, structural integrity of the middle layer, which is actual filtration layer, which maintains that shape, it protects from the any abrasion and provides comfort. And the surgical masks are labeled, they are of different level, you can see. Now, level 1, level 2, level 3, like N95, this is also in USA we have F2100, in China it is YY0469 standard, where it is 3 micron, it is more than 95% filtration efficiency, and 0.1 micron it should be more than 30% filtration efficiency for surgical mask. As per ASTM, for 3 micron it is more than 95, and for 1 microns it is more than 95. So, that is how this is the there. I think there is something missing here, will not, but it is at a 3 microns it is there 95%, and it is not for 1 micron, this will be crossed here, this is not there. And for type 1, type 2, type 3 are for European standard EN 14683, for 3 micron it is 95, for level 2 98, and level 3 2R it is 98, and for 1 micron it is not for the 1 micron particles, 0.1 micron particle, this is not for the very fine particle. So, apart from this there are different other masks available. Let us discuss one cloth mask, fabric masks are available. This is the typical cloth mask made of the textile fabric, normal textile woven fabric, or maybe knitted non-woven cotton, polyester and blended fabrics are there. Here usually 2 to 3 layers of fabrics are used to block the droplets. Reusable and washable, these masks are washable, making them economical and environmental friendly. So, if we dispose the this type of non-degradable material, it will load the environment, environmental pollution will increase. So, primarily protect against the large respiratory droplets, provides lower filtration efficiency compared to medical mask. So, for large particles and for cheap material, if we want, for preventing the normal air dust. So, that for those application we can use this cloth mask. It is widely used for general public for community setting. So, this is performance depends upon the fabric, okay, and its compactness, thread count if it is used in woven fabric, and number of layers. And KN95 mask, this is the KN95 mask, that variant, it is similar to the N95, and this is a Chinese respiratory mask under Chinese standard GB 26 standard. It is actually designed to filter 95% of airborne particles, structural similar to N95 respirator. This is similar to KN95 is Chinese, as per Chinese standard. It is similar to N95. It consists of multiple layer of nonwoven, including melt blown and spun bonded layer. So, it is with ear loops there, used for healthcare, industrial worker, public protection. Another mask is a FFP mask, okay, European respiratory mask. So, this is the FFP mask. So, as per European standard EN 149 certified, available in 3 classes FFP 1, 2, 3 based on the filtration efficiency. So, FFP 2 provides the protection comparable to N95 and FFP 3 often provides higher filtration efficiency. It is typically around 99% highest filtration efficiency it provides. So, it is used for healthcare sector, laboratory, construction and industrial workplaces they use. Again it is made of multi-layer nonwoven, like mainly spun bonded, melt blown structure, multi-layer structure, and some of the models include the valve for easy breathing. Also, in addition to the nonwoven, if we want to absorb some volatile chemicals, poisonous chemical, so we can use activated carbon. So, activated carbon masks are available. So, that is there, and this contain activated carbon layer addition to the normal filter layer. So, what normal filter layer we know that it capture the particles, but activated carbon helps in absorbing the odor, gases and chemical vapor. So, chemical vapor with a very fine particles that may not be actually captured by the normal filtration. So, activated carbon is used to enhance, to absorb the absorb all these gases and vapors. So, commonly used in polluted environment, provide protection against dust, smog and unpleasant smells. So, that for that it often used in combination with other filtration layers, but it is less effective than respirator for very fine air pathogens. So, here activated carbon only if we want to use, the filtration efficiency will not be that high, but if we use as one of the layers along with the other layer, then we can get its advantage of absorbing the chemical vapor gases. So, it is used daily pollution protection rather than medical use. So, elastomeric respirator. So, this is the elastomeric respirator, where it is it can fit with the different shape. So, reusable respirator made from durable rubber or silicon material. So, here this is the durable rubber or silicon material, but there the filtration zone, that their filter can be replaced. So, this is durable and it is a reusable respirator, where reusable or replaceable cartridges are used or filtered disc. This is a filtered disc that can be replaced, keeping the structure intact. So, it provides very high filtration efficiency and strong facial seal. So, there will not be any gap. So, for very dangerous gas leak or very challenging environment, we use this type of elastomeric respirators, commonly used in industrial and chemical industry or in laboratory environment, where the poisonous gases are there. So, it can protect against dust, aerosol and certain gases depending on the filter type. More durable and long lasting than disposable masks, require regular cleaning, maintenance and filter replacement. So, filter replacement should be there on the regular interval. Now, try to understand the different types of materials which are used in this face mask manufacturing. So, nonwoven face mask, actually that nonwoven layers are used, as we have discussed. Spun bonded nonwovens are used. So, this is the spun bonded fabric layer which are used as a outer layer even on the inner layer, and spun bond process is actually extruded polymers are extruded from the through the filament, and then they are lying on a conveyor belt and subsequently they are bonded together. Filaments are bonded together. Here you can see this is a polymer chips and extrusion is there, spinning die, that is a spinneret is there, through which the filaments are falling on a conveyor belt. Depending on the speed, the thickness of the fiber waves can be controlled, and finally, they are bonded by calendering or by needle punching or by different other means, and ultimately we get the nonwoven fabric. So, here the fibers are relatively coarser, 15 to 35 micron as compared to melt blown. Melt blown we get very fine particles, fine fiber diameters, and this spun bond provides a mechanical strength and durability to the structure, multi-layered structure, usually used as the outer and inner layer of the mask that we have already seen. It includes droplet resistance for the, and it supports the structure and creates the comfort, the inner layer. So, outer layer should be droplet resistance, inner layer is provides comfort, and both the layers they support the main melt blown structure. So, it is widely used in surgical masks and N95 respirators, and melt blown technique is that made by blowing molten polymer with high velocity hot air, and in that when the molten polymer is actually coming under the high velocity air, hot air, it gets stressed further. So, you can see here this is the process, hopper extruder is there, metering pump is there, the molten polymer is extruded through the die, that is a spinneret, and then hot air is blown. Hot air is further it stretches the this filaments, and the wave is deposited on the collector, and ultimately after bonding we get very fine fiber, the melt blown structure, and it forms a high surface area wave with excellent filtration properties. It often electrostatically charged. So, electric charge we can to enhance the particle capture, as we have already discussed. Used as a main filtration layer in the mask. So, this is the melt blown is used as a main filtration layer. Spun bondeds are they have their different function, and it used to filter the bacteria and particle filtration. And nanofibers are also used in the mask. So, it is produced by electrospinning technique or advanced nanofiber technology. So, this is the electrospinning process, where fiber have diameter 100 to 500 nanometer, creates extremely small spores with high surface area, which provides excellent filtration efficiency, but here we need one substrate. So, over the spun bond or melt blown we can generate one very fine melt that electrospinning the nanofiber layer, which enhance the filtration efficiency, and it can achieve very high filtration efficiency with low breathing resistance. So, a pressure drop is not that high, does not increase to that extent, and it is used an advanced or next generation respirator mask. So, there we can use and being researched that to improve the mask like N95 respirator. So, N95 respirator, if we add another layer of nanofiber, then the filtration efficiency can be increased to a greater extent. So, polypropylene is used because of its low density, which produces lighter weight, and it improves the wearer comfort. So, it is excellent melt possibility. So, we can produce a suitable for spun bonded and melt blown production because of the lower melting point. Hydrophobic it is nature, it naturally repels the water droplets from the outer mask. Good fiber forming ability, and chemically inert, non toxic. So, electrostatic charge retention capability is good. So, in melt blown we can charge it, and it charge decay time is longer and cost effective, widely available material. So, other fibers, polyester can be used due to its good strength and durability, and we can reuse if we do it. We can reuse cotton, can be used, it is natural, breathable, comfort, we can use in the inner layer also, commonly used in cloth mask and reusable face covering. Cotton can be used, polyethylene can be used as it is lightweight and it is good chemical resistant, and it is occasionally used for specialized filtration layer. Polyamide is also used, offer high strength and stretchability, can improve fit and elasticity of certain mask designs. Nanofibers, as I have mentioned, it will provide high filtration efficiency due to its high surface area and lower diameter. Advanced filtration layer we can use. Although all these fibers used, the polypropylene remain the most widely used in the mask, surgical mask. and N95 respirator due to its filtration efficiency and lower cost. So, and as we have already discussed, the lower melting temperature, we can, the meltability is or spinability is very good, and sustainable aspects we can also consider. Environmental concern is there because the disposable mask, we can immediately, we should try to use the recycling approach. These fibers are non-degradable, non-biodegradable polypropylene fiber. So, large waste generation is there which actually give environmental pollution, it generates environmental negative impact is there. So, reusable masks are used, we can use that cloth mask which can be reused. Biodegradable materials can be developed like natural fibers, so PLA, cellulose. So, that type of materials we should use to make it sustainable, and recycling of the mask, that after disinfectation. So, that we can use that recycling approach to reduce the or minimize the environmental impact. So, after COVID there are few advancements are there. So, hybrid electrospinning is developed. So, where the two different polymers are used to make hybrid electrospun non-oven, and here the two polymers are blended, we are getting a blended polymer to have special characteristics. We can get the core sheath coaxial electrospinning, like core sheath type structure. We can generate the emulsion polymerization. So, emulsion electrospinning we can do. So, side by side electrospinning we can get. Okay. So, different types of structures we can create. Antimicrobial, antiviral coating we can apply, which actually kill the virus or bacteria on the surface during its penetration. So, this is the self disinfection inspecting the antimicrobial coating. So, that this is the some virus is coming and it gets trapped and killed at that stage. So, incorporation of silver nanoparticles, copper or antimicrobial agent helps in inactivate the microorganism and trap the mask. So, that they will inactivate the this microorganisms and it will be trapped inside the mask, reduce risk of secondary contamination during handling as they are inactivated. So, reusable and regeneratable mask. After sterilization, multiple sterilization, we can reuse the mask. That approach we should use. We should include the UV treatment or heat treatment, okay, hydrogen peroxide sterilization. That these approaches we can use to reuse the mask. So, we should aim to reduce the waste from the disposable mask, and biodegradable mask is also one approach where we use the fibers PLA, cellulose, chitosan fibers we use, and the basic challenge is the environmental pollution is the challenge of all these masks. So, that we have already discussed that we can use the reusable mask, or we can biodegradable fibers we can use. So, balancing the filtration and breathability is important. So, we should keep the filtration efficiency high, at the same time breathability should be kept intact. So, increasing the filtration efficiency often leads to higher airflow resistance, making the breathing normal breathing difficult. So, proper fit and sealing is the issue, because the otherwise the pollutant can penetrate through the opening. So, many masks do not fit well, causing air leakage and reduce the protection. So, that issue we should address, and limited reusability, as we have mentioned. So, it enhance the cost and creating the environmental challenge. Disposal and waste management is issue. Okay. Actually, contamination, environmental contamination and microplastic pollution, it enhances. So, maintaining filtration performance is important, and we can use the electrostatic charge to enhance the filtration performance, but over the time it even after sterilization it actually lost its electrostatic charge. That issue we should address. So, the overall conclusion is that face masks are essential for reducing the transmission of airborne particle and respiratory diseases. Masks performance depend on the material selection, multilayer structure, what type of multilayer structure we are selecting, and proper fit. Non-woven polypropylene material is actually particularly spun bonded and melt blown plays key role in mask filtration. Technologies such as nanofiber generation on the filter medium for improving the filtration efficiency and comfort. So, growing concern over environmental impacts has to be addressed, and the research should focus the reusability and biodegradable mask, and future development aims to achieve high protection, better comfort and sustainable material. So, here we have completed the part 1 of this course, that is textile for human protection, and we will do the next course, we will start the next course later. So, next course will contain different aspects that we will discuss. Till then, thank you.